Hi, this is Asing. You are now watching Asing Math TV. Today we'd like to share how to find the Maclaurin series of e to the power of tangent x. Since differentiating e to the power of tangent x is not an easy task, so I'm going to split the function into two different functions. Firstly, we let fy be equal to the power that is tangent. Since I'm using variable y, so remain y over here. And at point y is equal to 0, tangent 0 is equal to 0. Now differentiate the function with respect to y. Differentiate tangent, we obtain secant square. By using trigonometric identity, we obtain 1 plus tangent square y, which means that at point y is equal to 0, we have 1 plus 0 square is equal to 1. Now differentiate the function for the second time. When we differentiate constant, we obtain 0. Which means that differentiate 1, we obtain 0. And now differentiate tangent square y by using chain rule. So power bring down, we have 2 here. And power loss 1, 2 minus 1 is equal to 1. Variable remain. And differentiate tangent, we obtain secant square y. If you are not familiar with this chain rule, let me show you here step by step. We can first let v be equal to tangent square y, while u is equal to tangent y, which means that v is equal to u squared. If we differentiate v with respect to u, we should have power bring down 2 and power loss 1. 2 minus 1 is equal to 1. Now differentiate u with respect to y, we obtain secant square y. What we need here is dv dy, but we only have dv du and du dy. If you treat them as unknowns and take multiplication, we can eventually eliminate du and obtain dv dy, which is the terms that we are looking for. Which means that we just have to take 2u multiplied with secant square y, and u is equal to tangent y. And this is the terms that we actually looking for. Now again apply trigonometry identity. So we have 2 tangent y multiply 1 plus tangent square y. So we should have 2 tangent y plus 2 tangent power 1 multiply power 2. By using law of indices, we have 1 plus 2 equal to 3. Which means that at point y is equal to 0, we have 2 multiply 0 plus 2 multiply 0, which is equal to 0. Let's differentiate for the third time with respect to y. Differentiate 2 tangent y equal to 2 secant square y. And we plus 2 tangent cube y, again apply chain rule. So power bring down 2 multiply 3 is equal to 6. Power loss 1, 3 minus 1 equal to 2. Differentiate tangent, we obtain secant square y. Since all we need is up to the term including x to the power 4. From here, we should observe that the series expansion of tangent should have a value of 0 for every odd term. So which means that we don't have to differentiate further. Since I'm not going to differentiate further, then I won't apply trigonometry identity again for this line. So we can determine the value at point y equal to 0. So we have 2 secant y is equal to 1. So we have 1 square here, and we plus 6. Tangent y is 0, so 0 square. Secant 0 is 1, so 1 square here. In other words, this is equal to 2 plus 0, or simply 2. Now with all these terms that we obtain, let's form the Maclaurin series of tangent y. For the first term, we have 0 over 0 factorial y to the power of 0 plus the first derivative 1 over 1 factorial y to the power of 1 plus the second derivative 0 over 2 factorial y to the power of 2 plus the third derivative 2 over 3 factorial y to the power of 3 and so on. If you notice carefully, when I take the first term, since this is the original function, so I will have 0 factorial and power 0. When we come to the first derivative, which means that I have 1 and 1. Second derivative, 2 and 2. Third derivative, 3 and 3 and so on. So by using this method, we don't have to memorize the formula and we should form the Maclaurin series easily. Now let's simplify, which is equal to 0 plus y plus 0 plus 2 over 3 factorial. Take note that 3 factorial is equal to 3 times 2 times 1, which is equal to 6. And what we need here is 2 over 3 factorial, which is 2 over 6, or equivalently 1 over 3, which means that we have y cubed over 3 here. After obtaining the Maclaurin series of tangent y, by replacing y with x, and we shall obtain tangent x is equal to x plus x cubed over 3, and so on. Now let's determine the Maclaurin series of the exponent. So I'm going to let gu be equal to e to the power of u, where u is equal to tangent x. At point u equal to 0, gu is equal to e to the power of 0, which is equal to 1. Now let's differentiate the function with respect to u. When we differentiate e to the power of u, we obtain eu again. In other words, at point u equal to 0, we will obtain 1 again. From here, we can deduce that at any derivative, we will always obtain e to the power of u, and the respective value of the function at point u equal to 0 will always be equal to 1, which means that e to the power of u is equal to 1 over 0 factorial u to the power of 0 plus 1 over 1 factorial u to the power of 1 plus 1 over 2 factorial u to the power of 2 plus 1 over 3 factorial u to the power of 3 plus 1 over 4 factorial u to the power of 4 and so on. And we should obtain 1 plus u squared over 2 plus u cubed over 6 plus u to the power of 4 over 24 and so on. With the two Maclaurin series that we obtain, we can now plug in and expand using algebraic power series manipulation. Since u is equal to tangent x and equal to x plus x cubed over 3, we ignore all other terms that are higher than x to the power of 4. So when we take u squared is equal to, we take x plus x cubed over 3 squared. Expand it and we shall obtain x squared plus 2x multiply x cubed over 3 plus x cubed over 3 the whole thing squared. And for the last term, we don't have to compute, since when we take the power 3 to the power of 2, we will obtain power 6, and this is greater than 4, where the term that we should ignore. In other words, for u squared, we just have to take x squared and 2 over 3 x to the power of 4. Now, for u to the power of 3, that is x to the power of x cubed over 3, the whole thing cubed, or equivalently, x plus x cubed over 3 square multiply x plus x cubed over 3 by using law of indices. We already obtained the one for u squared, so we have x squared plus 2 over 3 x power 4, and we just have to multiply x plus x to the power 3 over 3. Again, we should ignore any terms with power that is greater than 4. So all we need here is just x to the power 2 multiply x to the power 1, that is x to the power 3. Then we have u to the power 4. Again, we take u power 3 multiply u, that is x cubed multiply x plus x cubed over 3. So we obtain x to the power 4, and the rest again ignore. Now replace u with tangent x. So substitute accordingly. We have 1 plus x cubed over 3 plus x squared plus 2 over 3x to the power of 4. The entire term multiply 1 over 2 plus x cubed multiply 1 over 6 plus x to the power of 4 multiply 1 over 24 and so on. Expand and simplify. So we have 1 plus x cubed over 3 plus 1 over 2x squared plus 1 over 3x to the power 4 plus 1 over 6x cubed plus 1 over 24x to the power 4 and so on. So this is equal to 1 plus x plus 1 over 2x squared plus 1 over 3 plus 1 over 6x power 3 plus 1 over 3 plus 1 over 24x to the power 4 and so on. So this is equal to 1 plus x plus 1 over 2x squared plus, so we have 3 times 2 is equal to 6. So 1 times 2 is 2. 2 plus 1 is 3. So we have 3 over 6. And this is for the term x to the power 3. And the next one we have 3 times 8 is 24. So 1 times 8 is 8. 8 plus 1 is 9. So we have 9 over 24 here, and this is for the term x to the power 4. Which means that the Maclaurin series of e to the power tangent x is equal to 1 plus x plus 1 over 2x squared plus 1 over 2x cubed plus 3 over 8x to the power 4 and so on. And hence we done. Okay, that's all for this video. Thanks for watching. Hope you like this. See you.